Hey everyone, it's Justin again. In the last lesson, we graphed the reciprocal function 1 over x. Now we're going to see what happens when we take that graph and shift it around on the coordinate plane. By the end of this lesson, you should be able to identify translations of reciprocal functions in graphs and equations. First, we'll review the rules of vertical and horizontal shifts, also called translations, using functions that we know. We'll use that knowledge to explore the effects of these translations on reciprocal functions, and then we'll practice 3 examples. Let's look at translations of other functions before we look at reciprocal functions, so we can see how the process is similar. A few units back, we talked about transforming graphs by adding or multiplying different numbers in their equations. Here's a quick refresher. This graph shows the parent function, f of x, equals the square root of x. As a reminder, a parent function is the simplest form of a function.
So if the square root of x is the parent, its children might be things like the square root of x minus 3, the square root of 2x, or the square root of the quantity x plus 4.
Each of these changes will have a different effect on the graph. For example, let's look at the square root of x minus 3. All the y values from the parent function are moved down 3 units. The square root of 0 minus 3 is negative 3. So the point at 0 would move down to a y value of negative 3. Similarly, the y value of 1 would move down to negative 2. So this ends up becoming a vertical shift of down 3. How do you think adding 4 inside the square root would change the graph? If you were thinking this would be a horizontal shift, you're correct. And remember that there's a slight twist with horizontal shifts. On the x-axis, the positive direction is to the right. But adding 4 inside the square root will actually move the graph 4 units to the left. The movement of the graph is the opposite direction that you might expect for a horizontal shift based on whether the number is positive or negative. Keep this in mind, since it's very easy to go the wrong way, but you can always double check that you have the right equation for the graph by just plugging in a point. If we plug in negative 4 for x, this function becomes the square root of negative 4 plus 4, which comes out to 0. That matches the y value of the point, so we know we have the correct point plotted at negative 4, 0. Let's keep this in mind as we move forward. A vertical shift is created by adding or subtracting a number from the function as a whole. A horizontal shift, on the other hand, is created by adding or subtracting a number from x specifically wherever it appears in the function. To perform a horizontal shift, you have to replace any x's with x plus n or x minus n. In our square root example, that was the difference between adding or subtracting outside of the square root versus adding or subtracting inside the square root. How do you think we'll represent this difference between horizontal and vertical shifts when the parent function is 1 over x? Now that we've explored translations with a function we already knew, let's explore translations of the reciprocal function 1 over x. So what would the graph of 1 over x plus 2 look like? Well, since this plus 2 is just tacked on to the end of the function, this is a vertical shift. For vertical shifts, we go the direction you would assume based on the 2 being positive. Every point on the graph would be shifted up by 2 units. So this is what it would look like. There's an interesting change in one of the properties of this graph now that it's shifted. To make it easier to see, let's just look at the new graph. Can you see what important property is changed? Here's a hint. It rhymes with quasymptote. Remember, the parent function 1 over x has asymptotes at both the x-axis and the y-axis. But where's the horizontal asymptote now? On either end, this graph appears to be approaching the y value of 2. So that's where the new horizontal asymptote is, at the line y equals 2. Just like the rest of the function, the horizontal asymptote also got moved up by 2 units. Also note that even though this was a vertical shift, the vertical asymptote is still in the same spot. Since it stretches infinitely far vertically, moving the graph up or down won't change it. Imagine moving this infinitely long vertical line up or down. You wouldn't be able to tell the difference. So when 1 over x is shifted vertically, the horizontal asymptote only gets shifted by the same amount. With this in mind, can you make a guess as to what will happen when 1 over x is shifted horizontally? The vertical asymptote only would get shifted by that same amount. Let's graph a horizontal shift to make sure that that's true. Here is the graph of 1 over x shifted 1 unit to the right. Where's the vertical asymptote now? Just like the rest of the graph, the vertical asymptote has been shifted 1 unit to the right. And similarly to the vertical asymptote, in the last example, the horizontal asymptote stretches infinitely far horizontally, so moving the graph left to right doesn't change that. Now, can you figure out what the equation would be when we move 1 over x 1 unit to the right? There are two things to remember. One is that a horizontal shift happens wherever x is, unlike a vertical shift, which is just the number tacked onto the end of the equation. And the other thing to remember is that it's the opposite direction of what you might expect. For this graph to move 1 unit in the positive direction of x, we need to subtract 1 in the equation. So the equation of this graph is 1 over the quantity x minus 1. Just like we did with the square root equation at the beginning, we can make sure we have the correct graph by plugging a point into the equation. So let's choose 2, 1. How can we use this point to make sure that we found the correct equation? We could just plug in the x value and see if the output is the y value. At 2, this function has a value of 1 over 1, which is 1. That matches our y value, so we can be confident that we adjusted the equation correctly. Before we move on to examples, let's review the rules for asymptotes of translated reciprocal functions. The parent function, f of x equals 1 over x, has a horizontal asymptote at the line y equals 0 and a vertical asymptote at the line x equals 0. The function 1 over the quantity x minus a plus b has a horizontal asymptote at y equals b and a vertical asymptote at x equals a. Notice that this equation has minus a for a vertical asymptote at x equals positive a. We take the opposite sign to find this vertical asymptote. So, if there were an x plus 5 in the denominator, the vertical asymptote would now be at x equals negative 5. And if you don't see the minus a or plus b, this just means there's no shift in that direction, and the asymptote would be at 0. So, in the case of this 1 over the quantity x plus 5 example, since there is no plus b, the horizontal asymptote is at the line y equals 0. And remember what we mentioned earlier. Vertical shifts move the horizontal asymptote, and horizontal shifts move the vertical asymptote. All right, time to try out some examples. Which of the following represents the graph of 1 over x shifted 4 units to the left? Can you see which of the answers is correct? Remember that horizontal shifts happen where the x is located in the expression. This rules out the 2 answers on the left. These represent vertical shifts, since the 4 is tacked on at the end. And we also need to remember that for horizontal shifts, the movement is in the opposite direction of what you might expect. Left is the negative direction on the x-axis, so x plus 4 will be in the equation. So the correct answer is 1 over the quantity x plus 4. Our next example asks, what are the horizontal and vertical asymptotes of f of x equals 1 over the quantity x plus 1 minus 8? Luckily, we don't have to graph the function to know its asymptotes. We can tell what they are just from looking at the equation. So can you see what each asymptote would be? Remember, our guide for finding the asymptotes of a translated reciprocal function. The horizontal asymptote is the number tacked on at the end. In this case, since the 8 is being subtracted, the equation of the horizontal asymptote is y equals -8. As for the vertical asymptote, it's whatever is being subtracted from x in the denominator. Since we have x plus 1, you can think of it like the number being subtracted is -1. So the vertical asymptote is at x equals -1. And now we have both parts of the answer. We'll do one more example. The graph depicted is a translation of the parent function 1 over x. What's the equation of f of x? Here's a neat trick we can use for questions like this. Let's apply that same formula we were using to find asymptotes. This time, we can go backwards and build the equation from the asymptotes we see. So can you see where the horizontal and vertical asymptotes are on this graph? They fall on the lines y equals 4 and x equals 2. That means, according to these equations, the value of b is 4 and the value of a is 2. Now we just substitute those values into our equation for f of x, and the equation from this graph should be 1 over the quantity x minus 2 plus 4. We can verify our answer by plugging a point from the graph into our equation. What point would you choose from this graph? Try to get a point with whole number coordinates so it's easy to plug in and calculate. Let's use the point 1, 3. The point 3, 5 would also be good if you found that one. If we plug 1 into this equation, we get 1 over the quantity 1 minus 2 plus 4. 1 minus 2 is -1, and 1 over -1 is just -1. -1 plus 4 is 3, which makes the y value of this point. This input gave us the correct output, so we can be confident that we have the right equation. In this lesson, we discussed translations of reciprocal functions, but translations are only one type of transformation. In the next few lessons, we'll explore some other ways the graph of 1 over x might be altered. See you then!